Okay, let's look at this. 3 to the negative 1 equals negative 3. We want to know if it's true or false, and we want to support our answer, okay? Well, here's the deal. New exponent, okay? We've done positive integer exponents, which is natural numbers. The 1, the 2, the 3. We know, ... We know that something to a positive integer exponent means to use that base that many times as a factor. That's the definition. We talked about that in mod, I don't know, 2 or 3. Now, today in the last lesson, we talked about a zero exponent. Anything raised to the 0 power is 1. But we have not talked about negative exponents. I mean, that can't have the same definition that this has. Because that would mean, what? That use 3 negative 1 times as a factor? It makes no sense. So that's why everything needs a new rule. Natural numbers had a rule. 0 has a rule. Now, negative exponents have a rule. Now, I could just give you the rule, but that wouldn't be any fun. So I'm going to show you a little pattern. So take a look at your next slide, which we have this written down, and let's do this. Okay, 3 to the 5th. 3 to the 5th is 3 times 3 times 3 times 3 times 3. Okay, and what is that? 3 times 3. Let's see, 3 times 3 times 3 times 3 times 3 times 3, right? That's 5, right? 3 times 3 is 9. 3 times 3 is 9, so that's 81. 81 times 3 is 243. So this is 243. 3 to the 4th is 81. 3 to the 3rd is 27. 3 to the 2nd is 9. 3 to the 1st is 3. 3 to the 0 is 1. Notice what's going on as we decrease in our exponents. We're actually dividing our answer by 3. So this divided by 3 is 81. This divided by 3 is 27. This divided by 3 is 9. This divided by 3 is 3. This divided by 3 is 3. So we have to divide this by 3 to get that answer. So 3 to the negative 1 power really means 1/3. 3 to the negative 1 power really means 1/3. I'm going to explain to you why. As we take a look at the next slide, okay, that's the work that's in your workbook. 3 to the negative 1 is 1/3. That negative 1, I'm really going to drive you crazy now. That negative 1 is truly not really a negative, the way you know a negative. It's really a little notation. 3 to the negative 1 power means this. This stands for reciprocal of. This stands for reciprocal of. So what this says, 3 to the negative 1 power, is the reciprocal of 3. Well, the reciprocal of 3, remember that's 3, means that you change the denominator to the numerator and the numerator to the denominator. Or some of you say flip it, okay? So that is the reciprocal of 3. That's what that negative exponent means, reciprocal of, okay? So take notice on your slide, it says negative exponents. 5 to the negative 2 power means reciprocal. 5 to the negative 2 means the reciprocal of 5 squared, or 1/5 squared. The reciprocal of 5 squared, or 1/5 squared, or 1/25. So that's what negative exponents refer to. So let's see if we can get a better understanding doing some of these problems. Okay, I'm going to explain this to you, but I have to tell you, I like method 2 better, but I have to show you method 1 at least first to explain why method 2 even works. So watch how this works. This means 4 times x to the negative 3 power. Well, 4 times x to the negative 3 power. This means the reciprocal of x to the 3rd. Okay, the negative means reciprocal of. The reciprocal of x to the 3rd, which is 1/x to the 3rd. So here's the way I could do this. I could just set it up just like this and go 4/x cubed. I could do it that way. That's beautiful. I'm going to show you an easier way. I look at this and go, well, this is the method I like. 4 is to the first power. Just leave it alone. X is to a negative power. It means reciprocal. I'm going to have to move that. Here's why this works. Watch. Okay? If you have a number, let's say we want the reciprocal of 2/5. What happens to the 2? Well, whatever's on top goes to the bottom. Whatever's on the bottom goes to the top. So watch what I can do. This 4 is just to the first power. That means it's just 4. But this is to the negative power. Just bring it down. If it's on the top, it's going to have to go to the bottom. It's just 4/x cubed. And that works as long as these are factors. We'll see why. But as long as these are factors, all you have to do is move it. I call it cross the line, change the sign of your exponent. That doesn't work, but if you say of your exponent, that doesn't, that doesn't rhyme. Cross the line, change the sign. So I crossed the division line, brought it down, I changed the sign of the exponent, okay? Because reciprocal means that whatever's up goes down, whatever down goes up. So it kind of makes a lot of sense. Let's look at this next question. And you can pick your own poison, and there's quite a lot of ways to do this. So let's take a look. Actually, there's probably 3 methods. I've only listed 2. Okay, all right, we want our answers with positive exponents only. So we don't want negative exponents. Here's the deal. I can do this like 1,000 different ways, but all right, maybe not 1,000, but a couple. Here's method 1 that we have, which I think is probably in the ebook, but which is also on the slide, is that I keep the base, subtract my exponents. However, I have to tell you, I don't like that method. I'm not even going to do that method. Here's the method I like. You ready? I look at the exponents. That's a positive exponent, leave it alone. That's a negative exponent, guess what? Go down. Negative exponent, go up. Because it is down, it's got to go up. Positive exponent, leave it where it is. Positive exponents stay, negative exponents leave. But only when you're attached by multiplication. Why? Hold on, we'll show you. Okay, and this is just x squared times x cubed. Now it's attached by multiplication. That's x to the 5th. Y to the 4th times y squared is y to the 6th. Because I keep the base and I add the exponents. So it's x to the 5th over y to the 6th. And that's it. All right, let's take a look. I put this in here to make you crazy. Okay, this is not a negative exponent. So this is what we were doing before. Okay, it's just a negative number. But the only thing being raised to the 4th power is the 3. So again, this is negative. Bring it down. 3 times 3 times 3 times 3, which is 81. So negative 81 is your answer. How about here? Same kind of thing. This is not a negative exponent. This is negative 3 quantity to the 4th power. This is going to be a positive 81 because the negative is also being raised. It's negative 3 times negative 3 times negative 3 times negative 3. By now you probably have that memorized. Okay, negative exponent. Well, the negative's down. It's going to go up. So now we just have 1 over a to the negative 4. That goes up. Change the sign. Okay, and we just have 1 times a to the 4th or just a to the 4th. You're done. If you don't like that, I'll show you what you could do. You might want to close your ears. Remember, this is the reciprocal of a to the 4th. You could do it like this. 1 over the reciprocal of a to the 4th is 1 over a to the 4th. Then you have to change this to a division problem because it's a then you have to change this to a division of fraction problem, which changes to a multiplication problem, which guess what you get in the end? Yes, this. So why go through all of that? Cross the line, change the sign, that's it, you're done. So the answer is just blatantly a to the 4th, very easy, because you have 1 times a to the 4th. What happens to the bottom? You have nothing left or a 1 as a placeholder. When you have 1 on the bottom, you have exactly what you have on the top. Okay, let's take a look at this. Again, 2 ways to do this. I'm going to do these all the same way, but because I don't want you going back for methods. You could add the exponents, but you know what I'm going to do? I'm going to move them. They both go down. Why do they both go down? They both go down because they both have negative exponents. Okay? Think of these as being up right now. Okay? So they both go down, which is 1 over x to the 12th. We are done. Was there another way to do that? Absolutely. I could have combined, added the exponents, and got x to the negative 12, which would get me back to here. Either way. But I'm going to tell you the problems get a little bigger, especially later on in intermediate algebra, and I'm going to give you one plan that works really easy. Okay? All right, we're going to try the next 4. All right, here we go, 5 through 8, and then I'm going to show you the steps I would take every time, no matter what the problem looks like. Because what happens is, later on, when you get really good at these, you'll come up with your own pattern, and that's okay. All right, so here we go, x to the negative 3 over y to the 8th. I'm going to move the x to the negative 3 because it's got a negative exponent. Cross the line, change the sign of the exponent. Y to the 8th is positive, it stays down. Don't bring that up. If you bring it up, it becomes negative. Okay, cross the line, change the sign. And that's it, you're done because I cannot multiply these. So that's it, that problem's over. Looked hard, not bad at all. Okay, factor by factor. Here's what we do. I'm going to put ones where I don't see an exponent because I need you to clearly understand that x is to the 1st power, y is to the negative 2 power, z is to the 3rd power, 3 is to the 1st power, x is to the negative 2 power. Okay, and y is to the 1st, forgot him, z is to the 2nd. So that negative 2 power is not for the 3 and the x, it's just for the x. So you need to understand that. I'm going to go factor by factor because remember we said this worked for factors. So x stays up, y, you know where it goes? Y goes down, z stays up, 3 stays down. You might want to put it in parentheses because when it's in the middle there it gets lost sometimes. X goes up, y to the first, it's positive, it stays down. Z squared stays down because it's positive. Now I just multiplied. X squared times x to the first. We're multiplying, keep the base, add the exponents. X cubed, z cubed over 3. It's the coefficient, it goes in the front. Y, now I generally go alphabetical. That's the way we all generally go. Y squared times y is y cubed. Keep the base, add the exponents. Z squared has no friends. Oh, now, here's what I would do now. Now, you could have did this any point in time. Here's what I like to do. At this point, I like to reduce. Okay, you could have reduced in here. I like to wait to the end. Your preference doesn't matter. Okay, there are more z's upstairs. How many more z's? Just 1. So it's x cubed z over 3y cubed. We are done. So the rules I like to do, and it shows it on the next slide, okay, but we're going to do these too, but what I like to do is I like to do power to power if I have it, and I didn't have it, but if I have power to power, I like to do that first. Then I like to make all the negative exponents positive because I think people make less mistakes with positive numbers. Then I like to multiply. Then I like to reduce. Okay, so that's what I'm going to follow all the time, and that's up to you. But remember this power to power rule, and the moving up and down only works on factors. Okay, so let's go to this one. Speaking of that, power to power. Negative 4 times negative 7, keep the base, multiply, 28, I'm done. Ride's over. That was easy. Okay, let's take a look at this one now. This one's absolutely up to you because I could put z to 0 as 1. You know what? I'm not going to, and there's various reasons why I'm not going to. I'm going to just do power to power first. So everywhere I don't see a 1, any exponent, I'm going to put 1 as an exponent. This has an exponent, okay? So 5, keep the base, multiply the exponents. 1 times negative 2 is negative 2. Again, I like to do power to power first, okay? Keep the base, negative 3 times negative 2 is 6. Keep the base, 0 times negative 2 is 0, so I didn't hurt anybody. Keep the base, 4, negative 1 times negative 2 is 2, okay? And you could put a parentheses around there. I'm a little leery of that one because it didn't have parentheses to start with and it had an exponent, but that's up to you, okay? That's the same thing. 1 times negative 2 is negative 2. Y to the 2 times negative 2 is negative 4. So that's what I have. So I like to do power to power first, and then I like to make all my negative exponents positive. Okay? So here we go. I'm just going to erase number 6 in the front of this board so I have room. All right, here we go. So 5 to the negative 2, that's going to go down. That's going to become 5 squared. X to the 6, positive exponent, leave it alone. I got to be honest, I could just make this a 1 right now because it's 1 times this whole thing, which is just the whole thing, so it doesn't affect it. So I'm going to get rid of him. 4, positive power, I'm going to leave it where it is. That's 4 squared. X to the negative 2, he's going to come up. Y is going to come up because he's a negative exponent. So that's what we have. Okay, now, on the top, I have x to the 8th. Where did I get 8? Keep the base, add the exponents because I'm multiplying. Y to the 4th. And now here, the bases do not match. I'm going to need order of operation. This is 25 times 16. 25 times 16 is 400. And that's it. X to the 8th, y to the 4th, over 400. Not the only way to do the problem, but I'm going to follow those steps on that other slide, which is power to power, make negative exponents positive, multiply, and reduce if I can. I couldn't reduce here, but if I could, I would right there at that step. And that's it. If you follow those steps, you really can't go wrong. Okay, now I'm going to ask you to do the next 2 problems on the next slide that say true or false. They look almost alike, but they're not exactly alike, so we can explain something to you. All right, we want to know if these are true or false. Well, take a look at this. This is 4 times the reciprocal of 8 to the first power, or 1 over 8, and this is 4/8. So this is true. This is very true, which we knew, because we said with factors this works. For the first, you keep up. 8 goes down, and it's to the first power. So we knew that was true. That's what we've been saying the whole time. But take a look at this one. 4 plus 1/8. Well, to do 4 plus 1/8, we need a common denominator. Our common denominator would be 8. We'd get 32 over 8 plus 1 over 8, which is 33 over 8. This is not the same as this. This is false. So again, we've now showed that this rule of cross the line, change the sign only works on factors. That's what this next rule says. You have exponent rules that gives you the product rule, which we did in the last lesson, the quotient rule, which we did in the last lesson, the negative exponent rule, which we just did. Then if you go to the slide after that, more exponent rules. It gives you the power rule we did in this lesson, the combining, which we've done in the past, and the zero exponent rule, which we did in the last lesson. And then, in the next slide after that, there's all the rules and symbols if you'd rather have symbols. So all I'm going to ask you to do now is there's, I think, 5 or 6 more problems left. Just do those in your workbook. As soon as you're done, come back to the video and we'll check them for you. Please try to do those problems. Okay, let's take a look. Don't confuse negative coefficients to negative exponents, okay? This negative 4 has a coefficient of 1. This 2 has a coefficient of 1. So here we go. There's no power to power, so I'm going to make my negative exponents positive. So this is negative 4. A goes down and becomes a to the 4th. 2 is to the first power. It stays down. Okay, a squared is positive. It stays down also. So on the top, I have negative 4. On the bottom, I have 2. A squared times a to the 4th. We're multiplying, so we keep the base and we add the exponents. Now we can reduce. 2 goes into 2 once, 2 goes into 4 twice, but just make sure we keep that negative. So it's negative 2 over a to the 6th, and that's it. And we're done. All right, so that was pretty cool. He got lower, didn't he, there? Okay, let's take a look at this guy. 8 to the negative 3 power. There's no power to power. I'm going to make my negative exponents positive. So we have 8 to the 3rd. X to the negative 2 power, that's going to go down. Y is going to stay up because it has a positive exponent. 8 is going to go up because it's got a negative exponent. Okay, X is going to go up because it's got a negative exponent. It becomes positive when you cross the line. Y is on the bottom and it's positive, so it's going to stay there. Now, here's the deal. No way am I going to do 8 to the 9th. That is a huge number, and I don't really care what it is, and I'll show you why. But I'm going to put the coefficient in the front, 8 to the 9th. I don't really need those parentheses unless you want them. Okay? This is x squared y to the 4th over 8 to the 3rd. I'm not going to do that one either. And it's because I didn't do that one. That's not that big, though it is kind of big. It's not clearly as big as that one. We're going to talk about it. And this is x squared y to the 8th. Now, I'm going to reduce. Here's why I didn't worry about this and multiply it out, because now they have the same base. Since they have the same base and there's more 8s upstairs, I can make that a 1, keep the base 8, subtract the exponents. 9 minus 3 is 6. And then x squared, same thing, good night. Y to the 4th, y to the 8th. There's more y's downstairs. There's 4 of them. So it's y to the 4th. So on the top, I have 8 to the 6th. And on the bottom, I have y to the 4th, and I can leave it just like that. Done. Awesome. Hope I didn't scare you with that big 8. Okay. Ready for the last, not the last one, but for number 3? Here we go. Power to power, I have it. Negative 3 to the negative 2 power, x to the negative 2 power, y to the negative 6 power. Okay? What most people do is they multiply the coefficient with the exponent. You're not doing that. You're keeping the base, multiplying the exponents. Be careful. Okay, these are all negative exponents, so guess what? They all go down. Negative 3, you don't change the sign of the coefficient, you change the sign of the exponent. X squared y to the 6th. That is really easy to do. The whole thing is being raised to the square power. Negative times a negative is a positive 9. X squared y to the 6th. I love these. They're so much fun. Okay, that's 1, 2, and 3. We got 3 left, and then we can finish off this lesson. Okay, let's take a look at these last 3, and we can call it a lesson 13, right? Oh, 3. What the heck do I know? Okay, here we go. All right, putting 1s wherever I don't see an exponent for the exponent. Keep the base 2, Again, multiply the exponent. 1 times negative 1 is negative 1. X, 2 times negative 1 is negative 2. Negative 3 times negative 1 is 3. On the bottom, same thing. Keep the base. Negative 3 times negative 2 is 6. Keep the base. 1 times negative 2 is negative 2. Okay, we're moving. All right, here we go. I'm going to use a different color because it's getting kind of squishy. Okay, 2 to the negative 1 power. Squishy is not really a math term, but you can't squish stuff. 2 to the negative 1 power comes down, becomes 2 to the first. X to the negative 2, x squared comes down. Y cubed is positive, stays up. X to the sixth is positive, and it's on the bottom. Leave it there. Okay, y to the negative 2 is on the bottom. It needs to come to the top because it's got a negative exponent. So it's y squared. Now, we're going to multiply. Keep the base, add the exponents. That's y to the fifth over 2 to the first power is 2, x to the eighth, because we're going to add the exponents again. This is a great marker, very black. I like this one. Okay, that's it. That takes care of that problem. And now follow the steps that we were doing. All right, let's take a look at this one. This is interesting. This is one term. This is another term. So this is 1 over 4 squared. But I can write this like this. 3 over 2 to the first. Do you all see why? These are factors. This is a positive, it stays up. This is a negative, it goes down. This is a separate term. They have to be done separately. That's what that question I asked you about true or false, that things only work on factors. So terms must be done separately. So this is what we have, which is 1 over 16 plus 3 halves. The LCD is 16. We multiply by 8. We multiply by 8. We get 24, which is 25 over 16. Cannot reduce. You are done. Okay? Ready? Feeling good about this. Power to power. We have power to power here and only there. So we have 5. 1 times 3 is 3. X to the 6. X to the negative 2 is not in the parentheses. Plus, now we can do this separately. X to the 15th is positive. X to the negative 11th is negative. It goes down. Now watch. Still more fun. 5 cubed is 125. X to the 6th, but the square can go down. So I have 125 x to the 6th over x squared. And I'm going to move him down a little bit because I'm getting in the way here. So let's try that. I could show you, make sure you know where I got that. 5 cubed. 5 times 5 times 5. 125. X to the 6th. I did it again. I need a raise. Okay, here we go. Over x squared, because these are positive exponents, this is a negative, plus x to the 15th over x to the 11th. Okay? Now, we can reduce. You ready? Here we go. There's more x's upstairs. How many? 4, because 6 minus 2 is 4. So this is 125x to the 4th plus. We can reduce. There's more upstairs. How many more? 4. Oh, that is just a beautiful problem. I can combine them because they are like terms. 125 plus 1 is 126. Keep the like term. Oh my gosh, if you got that, you can do anything. That's a beautiful problem. Great marker, too. Okay, that ends lesson 3. Next time, lesson 4.